The last method we want to test is the CompareTo method. So let's go ahead and test that one. I think this won't be that difficult now that we've done equals. So let's look at the method here. We've got these 4 conditions here that have simple branches. Okay, each of them have 2 branches. So just like the equals method, what would it take to get us to return 0? Well, if we're comparing 2 persons, they're going to return 0 if those persons are equal. Okay, so if their names are equal, if the birthdays are equal, if the genders are equal, the email addresses are equal, they're going to return equal, because these are all saying if the names, this is saying if the name's not equal, then return a comparison, return either a negative number or a positive number. If the birthdays are not equal, return either a negative number or a positive number, and so on and so forth. Okay, so we want to get here. We want to return 0. And we can do that with Fred and Fred2 pretty easily. In fact, if we just go back up and look at this test equals Fred and Fred2, we can just grab that method and we can use that for test CompareTo. Okay, test CompareTo. And Fred2 is a new person with the exact same fields as Fred. And then we want to test if the CompareTo operator is 0. Okay, so we're going to do an assert true for this one. So Fred CompareTo, and we're going to put Fred2 in that, should be 0. Okay, so let's go back and look at our person class before we run this. And we see that nothing's covered in here and none of these branches are covered in here. The goal is to make sure return is covered, and these should all turn yellow. So let's check it out. Well, actually, let's go back. These decisions should turn yellow. But so line 130, for example, will turn yellow. But line 131 will still be red because we're not going to get to line 31. Okay? The idea is we're going to exercise one branch in line 130, then skip to 133, exercise one branch in there. So it'll be yellow, red, yellow, red, yellow, red, yellow, red, green. Okay, it's kind of good to try to guess what you're going to get as far as coverage is concerned, and then see if we come up with that. All right, so let's run this now, and we'll run it with coverage. All the test cases have passed. We've got a much higher coverage now. And there it is. It's yellow, red, yellow, red, yellow, red, and then green. Fantastic. All right, so let's start chipping away at these things. So if the names are not equal, then we return the result of a comparison of names. All right. So let's use Fred and Jane for that one because their names are not equal. In fact, look what I'm going to do here. I'm going to use Fred and Jane, and then here the names are going to be equal, but their birthdays are not equal. So for that, I'm going to do the Fred and Fred 2, and here the genders are not equal. I'm going to do the Fred and updated Fred 2, and here the email addresses. So I'm going to do something similar than what I did with the equals method. So I am just going to cut and paste those. So I already checked Fred, so I'm going to check Fred and Jane. Gender not equal, email not equal. I'm going to paste those here. Of course, it does not like that I'm using the same names for methods. But let's see. So instead of this equals here, I'm going to do a compare to Fred Jane. And then I'm going to do a compare to here too also. But I'm going to keep compare to birthdays not equal, because I really just need to understand what these test cases are doing. And I'm going to call that birthday instead of birthdays to be consistent. Do the same over here. Okay. So I'm comparing Fred to Jane now. And Fred's name is Fred with an F. Jane's name is Jane with a J. F comes before J. So the result of the comparison, this is going to be an assert true. So I'm comparing Fred to Jane, and it turns out that... All right, let me get this out of here. I'm comparing the names Fred and Jane, and it's going to turn out that the name Fred is alphanumerically less than the name Jane, because F comes before J. So therefore, since the inequality is in that direction, I'm going to assert true that Fred compare to Jane is going to be less than 0. So you want these inequalities going in the same direction. So if Fred is less than Jane, then Fred compared to Jane is going to be less than 0. All right, that's the easiest way for me to remember it. Okay, so test compared to birthday not equal. So Fred 2 is a person with not equal birthdays. So what do we have here? Is Fred going to be less than or greater than Fred 2? Well, Fred 2's birthday is greater than Fred's. Fred was born in 1980. So Fred is going to be less than Fred 2. Okay. So we're going to want the same inequality as we have in this one. Copy that, paste it, and instead of Jane, I'm going to do Fred2 there. And something similar for gender. Now here, you have to understand how enum types work. For enum types, each of these constants is assigned an integer. So actually, if you don't explicitly assign anything, the first one is assigned 0, and the second one is assigned 1, and if there was a third one, it would be assigned 2, and so on. So actually, male here is less than female. Male comes before female. All right? So it's going to be, okay, where's my gender not equal? It's going to be the same thing here. Assert true. Fred compared to Fred2 is going to be less than here. And what about this? This is the same thing. F comes before J in the email address, so all of these are going to be a less than. So let's see if this works. Let's first run the test this time. All the tests pass, and let's go run the coverage. And look at that. We're up to 100% coverage. So everything is covered now. Fantastic. So there's one little thing I'd like to do just to do a little bit of a sanity check. We've got all of these, Fred compared to Jane, less than 0. Fred compared to Fred2, less than 0, less than 0, less than 0. I'd kind of like one that was just greater than 0. All right, so what am I going to do here? Which one? How about the birthday? Okay. The birthday, let's make this birthday 2000. Okay. And now, if we run this, this test should fail. Okay, that test does not fail. Why does that test not fail? Okay, so Fred2 is a person with the same name as Fred. And Fred2's birthday is bigger than Fred. Oh, we want Fred2's birthday to be less than Fred. Sorry. So instead of 1990, well, Fred was born in 1980, so this has to come before. So let's say 1970. Let's say Fred2 was born in 1970. Now this test should fail. Let's run that. Okay, so I like to do, we did get a failure there. I like to do these just as a little bit of a sanity check. If I see all my inequalities going in one direction, I like to put at least one going in the other direction. If I have tests that pass all the time, for some reason that makes me nervous. I like to see failures every once in a while to know that there's not a glitch in the program. I know that sounds strange, but that's just the way it is. So I'm going to make this greater than 0 now. And now if I hit run with coverage, everything should pass and I should get 100% coverage. And there it is. Everything passes and we've got 100% coverage. So we have successfully tested our immutable person class.